Okay, we read today another integral. This one's from the Florida Integration Bee from 2012, round 2, problem 3. We have the integral of e arctan x over 1 plus x squared to the 3/2 dx. Okay, to get started with this one, there is some good news here. We don't really like arctan in the exponent, but the thing is we've got the derivative of that right here. If we kind of just create a 1 here, 1 over 1 plus x squared, not worrying about the 3/2 yet. So this setup is making me think a u substitution is going to work, or it has to work, because when we do u equal to arctan of x, we take a derivative, we're going to get 1 over 1 plus x squared dx. But I think rather than messing with this 3/2 exponent right now, let's actually take this and rearrange it. If I just take tangent on both sides, we can isolate x, and we'll get x equal to tan of u. Take a derivative, and now we have our dx value. This way we can write it as dx equal to secant squared of u du. So I'm almost ready to do my substitution this way, but I still want to deal with this 1 plus x squared part. What I can do for 1 plus x squared, we can get a value for it based on this one. If we know x is going to be tangent, then we know 1 plus x squared is going to be 1 plus tan squared u. But then we have the identity that this right here is the same thing as secant squared of u. So now we'll go ahead with this. I'm going to not even use this, and we'll just use everything else over here. So for our e arctan, that's going to become e to the u. This we said was secant squared u, but secant squared to the 3/2, the 2 is going to cancel, and I can write this as secant cubed u. And then our dx value is going to be this. So we have here secant squared of u. But then I can cancel out 2 of these with 2 of these, just leaving secant u. But then let's take that and just bring it into the numerator. And what we're going to have is going to be just e to the u cosine u du. But for this, we can just use integration by parts on this. We'll use the di method because we've got 2 functions. Let me just make a little space over here. Okay, for our di table over here to the right, we're going to differentiate cosine u. We're going to integrate e to the u. Just notice it really doesn't matter which I choose. These are just going to repeat. So you could kind of switch it and differentiate e to the u if you wanted. But let's just go ahead with this. So derivative of cosine u is going to be minus sine u. Do it one more time. This is going to become derivative of minus sine u is going to be minus cosine u. I stop here just because this is repeating what we had right there. Integrate e to the u. We get e to the u. Integral of e to the u. E to the u. So we can grab part of the solution on the diagonals here. The last row we're going to integrate. I'm going to put a label on this right here. Let's call this thing right here I. So then kind of copying everything down, I can factor out the e to the u we have in common. Here minus times minus is plus, so we can write this cosine u plus sine u. Now the last row of this integral, cosine u e to the u with a minus, that's going to be the same as our I values. This is just going to be like a minus I right here. But what I can do to clean this up, let's just add an I on both sides. Adding an I over here, I can write this as a really skinny 2. This is going to cancel over here. Let's just divide off this 2 to isolate our answer. Divide by 2 here. Just divide everything by 2. And pretty much all we need to do is just back substitute in order to finish this thing off. Okay, now one thing before we back substitute, notice I have a value here. We have a value for tan u, but we don't have a value for cosine u, and we don't have a value for sine u. So what I'm going to do for that is, let's just draw the triangle really carefully. If we know for tan u our angle's u, and we're saying that value, I can write it as x over 1. So we do opposite over adjacent as x and 1. Use Pythagorean theorem, we can find the third side to be just 1 plus x squared. Then let's get a value for cosine of u. That's going to be adjacent over hypotenuse, so it's going to be 1 over square root 1 plus x squared. And then let's also get a value for sine of u, opposite over hypotenuse, that's just going to be x over square root 1 plus x squared. But I think what I'll do is let's put it together, because what we really need is we need cosine of u plus sine u. We have a common denominator here, right? So we can put it all over square root 1 plus x squared. And then the numerator is just going to be 1 plus x. So then I can take this value and plug it back in for everything we have right here. So putting this together for the final solution, we have e to our u value, which is just arctan of x. In parentheses, we have this stuff. But what I can do is kind of break it up. We'll have 1 plus x, and then I can write the whole denominator with the 2 times square root 1 plus x squared, add a plus c, and that's it. Okay, there you go. Good one from Florida Integration B 2012. Thanks everyone for watching. Have a good day.